Hi, I'm Mark Cavanaugh for Cavi Coaches, and today I'm going to coach you up on how to use those kinematic equations we derived in the last video. We have our three kinematic equations here, and we have a problem that's provided by OpenStax, courtesy of Rice University. Thank you for providing a free college-level textbook for those of us in high school at the AP level. So we have our three kinematic equations, and in the kinematic equations, we have just 6 variables: initial and final position, initial and final velocity, acceleration, and time. So we can see that each of these equations is missing one of these variables. So we can see the first equation is missing position. We can look at our second equation, it's missing a variable. The variable it's missing is the final velocity. And our third kinematic equation is missing time. So how we're going to do this is we're going to read through the problem and write the information down, figure out what we're looking for, and one of these 3 variables is going to be missing along with the variable that we're looking for. So you can see I have them written in pairs. If you're missing one of the first pair, that means you're going to use the first equation. If you're missing the second pair, one of the second pairs, you're going to use the second equation. If you're missing one of the third pairs, then that means you're going to use the third equation. And by missing, that means you don't need it in any way at all. You don't need to find it. You don't need to use it in an equation. So let's go ahead and look at our problem. So we have a deceleration of 2.1 times 10 to the 4th meters per second squared. So it's slowing down, so we're going to write that value. It's decelerating, so that means it's going to be negative. So we'll write negative 2.10 times 10 to the 4th meters per second squared. And we can see we have an elapsed time of 1.85 milliseconds, or 1.85 times 10 to the negative 3rd seconds. It also tells us that the ball stops. So that tells us the final velocity is 0. It tells us nothing about the initial or final position. It's asking us for the initial velocity, so we're going to put a question mark there. And we can assume the initial position is 0 if it tells us nothing about the position. So now we can see that the only variable we don't know anything about and don't need is the final position, which tells us, since we don't know anything about the final position, we're going to go ahead and use the first kinematic equation because we're missing and don't need one of the first pairs. So now we go ahead and write that first kinematic equation. At this point, I know you want to plug numbers in. If you're taking an AP class, the last thing you want to do is plug numbers in. You want to use this equation and solve in terms of variables first, because most questions on the AP exam in terms of the free response questions do not have number answers. They're all symbolic answers in terms of a question such as the acceleration is ax, a time of t, and we want to solve for the initial velocity if it comes to a stop. So we're going to go ahead and solve this equation for initial velocity by subtracting the axt term. And we have our equation for initial velocity. Now we're going to go ahead and plug our numbers in at this point. And we check some units here, and we see that the seconds cancel out, leaving us with meters per second. And that is a unit for velocity, which is what we're finding. I forgot to make my acceleration negative, so we'll put the negative sign in there for the acceleration, negative 2.10 times 10 to the 4th meters per second squared. And now we just multiply those numbers together, take 0 minus the negative value, which is going to give us a positive velocity. And we find that that velocity is 38.9 meters per second. So what this number represents is how fast the ball was traveling the moment it hit the mitt before it came to a stop. So now last thing you want to check is, does this answer make sense? Can a person throw a ball at 38.9 meters per second? So a simple conversion to go from meters per second to miles per hour is you divide by 0.45. That converts to miles per hour. And when we do that, we get approximately 86 miles per hour. Major league players can throw upwards of 90 to 100 miles an hour. So yes, absolutely, a person can throw the ball at 86 miles per hour. So our answer makes sense. So this is how you use the kinematic equations. I hope you have a great day and an even better tomorrow.
If you found this video helpful, don't forget to subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter at Cavi Coaches.